Good afternoon. Right. On Tuesday we stop at section 5.3, 5.2. Sorry, about sum and difference of trigonometric function. So that's what we have from last time. So cosine of a sum or difference. For cosine, the side will be opposite, and but the function are the same. Cosine, cosine, sine, and sine. For sine, the signs in the middle are the same, but the function opposite. I should say different. Sine, cosine, cosine, sine, and tangent is that. So let's continue. Sorry, forgot to turn on the microphone. This is the one. Right. So on that sample here, right. So we have sine u is 7/25. Cosine v is -5/13. Both of them in quadrant 2. Now we should find cosine of u plus v. Right. Cosine of u plus v. For cosine, we have the same function. Cosine, cosine, and then sine, sine. And then the angle u, v, u, v. The function are the same in the product, cosine, cosine, sine, sine. But in the middle, the sign is opposite. If this is plus, it will be minus. Right. And into our problem, we have sine of u 7/25, 7/25, and cosine of v -5/13, which means we need to find sine of v and cosine of u. Right. So first, we find cosine of u. what we have is, for u, sine of u is 7 over 25. And u is equal to 2. Right, so that's what we are given. Right, now we write down sine of u is 7 over 25. So for a triangle, sine is opposite over hypotenuse, or y over r. So obviously r is always positive, so we choose r to be 25. And y is 7. So we just need to find x. And we have the Pythagorean theorem, x squared plus y squared equal to r squared. And so for x squared is r squared minus y squared, 25 squared minus 7 squared. 576. So to solve for y, so for x, take the square root on both sides. When there's a square root, to solve for it, there's square root, and then the plus or minus, and square root of that number is 24. Right, and then in quadrant 2, the point is here, and x values of a point in here is negative, so we choose negative. So x is negative 24. And finally, cosine of u is adjacent over hypotenuse, or x over r, negative 24 over 25. Right. We did this a lot in chapter 2, even chapter 1, and chapter 3. So we have cosine of u, so that's good. Now we need to find sine v. We do pretty much similarly here. What we are given is cosine of v is negative 5 over 13, and v in quadrant 2 also. Now we write out cosine of v, negative 5 over 13. Cosine is adjacent over hypotenuse. Adjacent, I draw the triangle. Adjacent is, and hypotenuse, or r adjacent is x with respect to this angle. So r is always positive, so we let r equal to 13, and because of that x is negative. Right. And then Pythagorean theorem, x squared plus y squared equal to r squared. So x squared equal to I mean, if we have x, so we solve for y square. R square minus x square, r square minus x square. And that should be 144. And now to solve for y, plus or minus square root of 144, which is plus or minus 12. And this is in quadrant 2, the y value will be positive if the point is in here, so we choose positive. And finally, sine of v, sine is y over r, y is 12 over r 13. Right, so that's good. And finally we put it back into this one. Let me zoom out. Right, and finally cosine of u plus v, cosine of u, cosine of v minus sine of u, sine of v. Cosine of u negative 24 over 25. Cosine of v negative 5 over 13. Sine of u and sine of v right, and do this. Common denominator will be 25 times 13. The top we have 24, negative 24 times negative 5. I'm just going to write everything. 24, negative 5. Subtract 7 times 12. Right, the top 24 times 5, negative times negative. Subtract 7 times 12. We have 36. The bottom is 25 times 13. 325. Right. So that's all we do. Right. So I'm going to post the test to after today, and this kind of problem certainly will be there. So you are given sine or cosine of u, sine or cosine of v, and then find the other one, and then we need to utilize these four formulas here. Right. Before we go to the next section, I just want to write this real quick. Notes. I will not ask you this on the test, but later on you might see it. What happens if you are asked to find what is cosecant of, for example, or secant? What is secant of u plus v? How do we go by in doing that? So secant of u plus v, first, secant is reciprocal of cosine. So, and we just need to do cosine of u plus v. So cosine of u, cosine of v, minus sine of u, sine of v. So that's the last note I just want to write before we go to the next section. So what happens if we ask to find secant or cosecant by sum or difference? Because if there's a difference, just turn this into a plus. Right. With that, we go to section 5.3. By the way, I did send you a formula and a unit circle, the formula on that side. Right? Along with the unit circle, a bunch of formulas. Right. So do have that. I'm going to switch between the formulas and the notes often. Right. Double and half angle identities. Right, first, double angle identities. Sine of 2u is equal to 2 times sine of u cosine of u. Next, this is a long one. Cosine of 2u is cosine square minus sine square equal to cosine square minus 1 or 1 minus 2 sine square. And then tangent of 2u equal to 2 tangent of u over 1 minus tangent square. Right, now we try to prove it. So to prove that, we have to use this formulas. By the way, I did mention on Tuesday that if we have to memorize something, some trig identities, those are the ones that we should memorize, because that would be very difficult to prove those identities. This is very easy to prove. So first, let's prove sine of 2u equal to 2 sine u cosine u. Right. So we start with the left hand side here. Sine of 2u. How to get 2u? We just do u plus u. It's very simple. Now we use that formula, but instead of v, we're going to use u. By that I mean this particular formula. There. So sine, the function will be different. So we have sine, cosine, and then cosine, and sine. Both of the angles are u though, so u and u, u and u. The sides in the middle is the same. Sine times cosine and cosine times sine, those two terms are the same. So that's why we have two of them. And that of course equal to what we have on the right side. So we start with the left hand side equal to the right hand side. So like I said, the proof for these identities are fairly simple. Maybe not this one, but the others are simple. So in real life, when we ask to find cosine of 2u, we can use any of this. By the way, I do send you the formula on of that. Right, so how do we prove it? Well, with the same thing as here. We start with the left hand side of cosine of 2u. And 2u is u plus u. And the formula for cosine of a sum cosine minus sine. The angles are U, both of them. Right, so this one obviously cosine times cosine is cosine square minus sine square. Right, so we have the first part of it. Now, to get to cosine square or sine square, that's fairly simple. What we have is cosine square plus sine square is equal to 1. If we want to solve for cosine square, we have cosine square equal to 1 minus sine square. Or if we want to solve for sine square equal to 1 minus cosine square. Right. And I will just substitute in either this one or this one. So first, if we use this, and we substitute into cosine square, so we'll have cosine square is 1 minus sine square. And do that, we have 1 minus negative, so 1 minus 2 sine square of u, which is that. Now, if we try something else, and we substitute sine square into this, so we have cosine square minus 1 plus cosine square, which is 2 cosine square minus 1. So pretty much exactly as we have here. So when we use it, we can just use that one, or that one. Any of it should work, but sometimes some will be easier than the others. And then tangent of u plus u, we write like that for tangent of 2 theta, which is tangent of u plus tangent of u formula over there, over 1 minus tangent of u times tangent of v, or tangent of u plus tangent of v. I mean, u and u, those are the same, so make it 2 tangent, and 1 minus tangent times tangent square u. So, like I said, proving these identities are very simple. So that's why don't even need to memorize it. Right. Now the example kind of like the last problem. I mean the first problem that we did today. Right. If cosine of theta is equal to negative 3/5 and equivalent to find the exact values for sine of 2 theta and cosine of 2 theta. Yeah, the problem in this section kind of like this. We have to know the identities and they would pretty much use it. Right. So we need sine and cosine of a double of an angle. Right. So it's what we have here, right? So we start with sine of 2u is 2 sine u cosine u, and then cosine of 2u is there one of those three formula. So we are given cosine. Let's use theta instead of u. So we are given theta, cosine of theta. We don't know sine. So the first thing we have to do is find out what is sine of theta, because we do need the sine theta. So cosine of theta is negative 3/5 for a triangle. Cosine is adjacent over hypotenuse, or x over r. So r is always positive, so we choose r to be 5. And x is negative 3 in this case. And then we just need to find y. Right. So x squared plus y squared equal to r squared. To solve for y squared equal to r squared minus x squared. 5 squared minus negative 3 squared. That is 16. Yeah, 25 minus 9, 16. So to get back to y, take square root of plus or minus 16 or plus or minus 4. Right. We do have this in quadrant 2. In quadrant 2, y above the x-axis, so y is positive. So that's going to be 4. And finally, we need to solve for sine. Sine is opposite over hypotenuse, or y over r. Right. So that's why we need to find sine, because in the formula we need to use it. Finally, sine of 2 theta equal to 2 sine times cosine. 2 times sine is the 4/5. Cosine is negative 3/5. When we multiply across, 2 times 4 times negative 3, negative 24, 5 square, 25. Right, so we have sine of 2u, sine of 2 theta. Now we go to cosine of 2 theta. We have a bunch of options. We can use this, this, or this. Right, what I'll use, I'm going to use the one that have the cosine, because that one is given, right? So I'm going to use this one, because that formula, the cosine theta, is given. So we have 2 cosine of theta is negative 3/5 square minus 1. Negative 3 square and 5 square minus 1. So 2 times 9 over 16, 9 over 25, sorry, minus 1. So we have 2 times 9 over 25 minus 1. So 18, common denominator of 25, we have negative 7 over 25. So pretty much just like what we did at the beginning of the class, we write out the formula for whatever being asked, sine, cosine, and determine what we are given and what we need to find. So in this case, we are given cosine and we need to find sine, and we do that. So we need cosine, we have cosine, now we need to find sine. Right, that's very simple. Next, number 2. I'll verify the identity sine of 3x is 3 sine x minus 4 sine cube. Right, how do we prove something like this? Right, sine of 3x right. So we have double angle. This is triple of an angle, but right. So to do that, we prefer to sine of 2u is 2 sine u cosine u. We know the double. So we do similar thing. In order to get 3 times the angle, if there's a 2 times, it will be plus itself. And if we have 3x, we can write x plus 2x. Is that? Of course, that will give us 3x, right? And sign of the sum is over there. Sine, cosine, cosine, and sine. Sine of x, cosine 2x, cosine of x, sine of 2x. Right, next we have a double angle here. So that is double angle. The sine is easy. This one we know is going to be 2 sine times cosine. We just need to know which one do we use. Cosine of 2x. Right. Good thing is, in this problem, we're trying to get to sine. So in the cosine of 2 theta, I'm going to use this particular part of the formula. Right? The cosine 2x is 1 minus 2 sine square and then cosine sine of 2x is 2 sine cosine. Right, and now I will multiply this out. Sine x times 1 sine and sine square. Alright, by the way, if this is confusing, I just want to mention this many times. Whenever we write sine square like this, we actually mean sine of x square and not sine of. I don't even want to write in the same. So that is correct. This is not. This is completely 2 different things. Because when we write like that, usually we mean sine of x squared, and this is sine of x first, and then we square it. So don't do this. Do that. So sine times sine square is sine cube. Now sine of 2x is this. We have cosine and cosine. We make a cosine square. Right. And up to this point, usually when we have a sine square and cosine square, that is the Pythagorean identity. So sine square plus cosine square is 1. So here we want cosine square. Want to solve for it? I subtract the sine square on the other side. And substitute into here. Sine x minus 2 sine cube x 2 sine x. Cosine square is 1 minus sine square. And now multiply it out. And then sine times sine square, again minus 2 sine cube. And finally, just combine like terms. we have sine x plus 2 sine x sine x, and then sine q minus 2 sine q minus 2 sine q minus 4 sine q. Right. Now, what's next? It's not even in the title. It said power reducing identities. So the title is double and half angle. However, this is very important. Not right now, but when we get to calculus, this will be probably the more common than the others. So what we call is power reducing. Right. So power reducing. So if we have a sine square, then we have 1 minus cosine of 2u over 2. If we have a cosine square, this is going to be a plus. And if we divide them, sine over cosine, which is that over that, the two cancel out. Right, proof. And to prove this is very simple. So we're building out what we are, what we already have, and what we already have is a double angle. Look at the proof though. We have cosine of 2u and cosine of 2u. So it's very useful that we need to use the cosine of 2u. So right, I don't have the power reducing here in the formulas, because usually when I'm teaching trigonometry class, I put that question on the test and ask you to prove it. Right, very simple. Notice that both of them have cosine of 2u. So that's where we start with the cosine of 2u. Cosine of 2u. Sorry. The formula for cosine of 2u or 2 theta is there. Of course we're not going to use this. because that have both cosine sine square, we're just going to use this if that's what we start with. We already know this. And if we go after the sine theta, we're trying to solve for it, what we do is we're going to plus 1 on both sides. I mean minus 1 on both sides. Or better yet, sorry, we solve for sine square. So better yet, why don't we, where's my, okay, I'm gonna add sine 2 sine square on both sides. We make sure that the angles are the same. Right. Subtract that on both sides. I mean add sine square on both sides. And then subtract the cosine 2u. So move this to the other side, it becomes positive 2 positive sine square of u. And then move this to the other side, that becomes minus. And then just divide by 2. So we have sine square is equal to 1 minus cosine 2u over 2. That's very simple. Just write out the formula and then solve for it. Now if we want cosine square, we can use this part of the formula. Sorry, this part. That part of the formula. Add that on both sides. And then divide by 2. So we have cosine of 2u plus 1 divided by 2. 2 and 2 cancel out. Cosine square, which means cosine square is 1 plus cosine 2u divided by 2. Right, like I said, the proof is very simple. What we build up, those are kind of the formula that, like I said, very difficult to prove those formulas. Now, when we know that, we can prove the double angle identity. We can prove the double angle identity. What we have the double angle, we can prove the power reducing. So it's very simple. Right. By the way, I take 5-minute break here because what we've been doing just proving a lot. So let's take a break now. We continue at 2:01. Right, we continue. Cosine to the fourth power of x. Right, first we have power reducing, right? Cosine square, that is the power reducing. Okay, we're going to use that one. So first, cosine to the fourth is cosine square, and then we square. So that's the first one. Now, the cosine square, we're going to use that for cosine square. Which is 1 plus cosine. For the power reducing, the power will reduce, but the angle is going to be double. So that's going to be 2x over 2. And there's still a square outside. Right. A square here meaning that it goes to the top, goes to the bottom. And the square meaning multiply by itself. Two squares 4. Right. Now multiply that. 1 times 1 is 1. 1 times cosine of 2x. Cosine of 2x. Cosine of 2x times 1. Cosine of 2x. And cosine times cosine. Cosine square. Cosine and cosine. Give us 2 times the cosine of 2x. And then cosine square over 4. So it's not bad. The only thing we do The only thing we actually did new is in this section is the cosine square reducing. Other than that, there's no thing. Right, now I will split 1 over 4 2 cosine 2x over 4, and then this I can write as 1/4, and then cosine square of 2x. Now what we have is once again a cosine square. We use the power reducing. 2 over 4 is 1/2 cosine of 2x. So cosine of 2x it's going to be the same thing, 1 plus the power is reduced but the angle is going to be double, so we're going to have 2 times that angle divided by 2, and then multiply it out one more times, 1/4 plus 1/2 cosine 2x. I will split this in 2. Multiply it out. 1/4 plus 1/2 cosine 2x. 1/4 1/2 is 1/8. 1/4 times 1/2 is 1/8. And finally 1/4 1/8 is 3/8. So 3 over 8, that is 8, plus 1/2 cosine 2x plus 1/8 cosine 4x. So that is where we're fully expanding the cosine to the 4th power. So the 4th power is square, the square again, and then when we have a square reduction power, reducing power, the power will reduce but the angle is going to be double. Same thing, the power is reduced, the angle is double, and then finally we simplify all that. Right, now we go to the 3rd part of the section, half angle identities. Right, so first the identities. Right. Sine of u over 2 equal to plus or minus one minus cosine of u divided by 2. The cosine of u over 2 plus or minus square root 1 plus cosine over 2, and tangent u over 2 is plus or minus the square root 1 minus cosine of u 1 plus cosine of u. The sine u 1 plus cosine and 1 minus cosine over sine. I'm going to do one of the proof. Right. Usually the proof is something work backward. The reason when we have plus or minus is if we square both sides. Square cancel the square root, and we just have this. Right? If we square both sides, that's what we have. Now, that look exactly like the power reducing, except the angle will change a little bit. So what we do here is, if we let u over 2 is x, solving for u, pretty much cross multiply, and we have 2x. So I will substitute 2x into u. U over 2 is x. And 1 minus cosine u is 2x. And that is the power reducing. So that's the proof. Now let's see how do we use them. I'll find the exact values of sine of 15 degree. Right. So obviously, thinking in context, what we study right now is half angle formulas. So we have to use the angle that involve half angle formulas. By the way, the formula is over there too. Right. Now, I'll write out the formula first. Half angle, half of an angle, plus or minus square root 1 plus, for the sine this is minus, 1 minus cosine of 2u over 2. Right. That's half of the angle. So pretty much in that case, what we have to write is sine of 15 now 15 is half of what is equal to 15, I should say. So instead of 15, we can say 30 degrees over 2, which is half of an angle according to the formula 1 minus cosine of 2 times the angle would be 30. Notice that this angle here and this angle here, this one is going to be double that. Right. First, is this positive or negative? Well, this is easy. For sine, make sure this is in degree mode. Sine 15 degrees, everything in the first quadrant is positive. So this is 15 degree in quadrant 1, therefore it's going to be positive. So we're going to use positive. Or we just rub it and we have 1 minus cosine divided by 2, 30 degrees. Right, cosine of 30 degrees cosine is square root of 3 over 2. Right, so quite often and not in the half angle formula. Usually we try to simplify this. And if I multiply top and bottom by 2, so 2 times 1 is 2, 2 and 2 cancel out, we have 2 minus square root of 3, square root of whole thing, divided by 2 times 2 is 4. Now split the square root. Square root goes on the top, and square root goes to the bottom. Square root of 4 is 2 at the bottom. The top, 2 minus square root of 3. Right. Just make sure that it is correct. We can always check alpha y equal to, give us a fraction. Square root of 2 minus another square root of 3 over 2. You see? So that's correct. However, the calculator did not give us this answer. That's why we need to do this by hand. But we can confirm that with the calculator. So that's first one. Now, next. I'll find the exact values of. I'm going to use the radian instead of 22.5 degrees. I'm using pi over 8. Is that? So again, this is half angle formula. By the way, if on the test and we see the radian measure, we can always change it back to pi over 8 change to degrees, put pi at the bottom, 180 on top. Pi and pi cancel out. 180 divided by 8. 22.5 degrees. So now, of course, 22.5, that look like half of 45, right? However, sometimes drawing like this is actually help. But before that, let's just write half angle formula. By the way, I did this on purpose and nobody catch that. There's no 2 here, right? This part of trigonometry is a lot of using the identities. Sometimes I mean most of the time it's pretty right, and we just look at the formulas, apply the numbers. So this could be complicated, but usually not much into it. But later on that may help a little when we switch to the other one. So pi over 8, we can just say pi over 8, how about half of pi over 4, because where we multiply across, that is pi over 8. And this we can say cosine of half of the angle, or we can say that. We don't even need to write like this. What we just have is half of an angle. Will be plus or minus square root of 1 plus cosine. In the half angle formula, we start from half, but when we put in the formula, it's going to be just the angle. So what we have here is, that is u. Right. Pi over 4 is u, so pi over 4. So we end up with square root before going further, should it be positive or negative? Once again, pi over 8 or 22.5, that is in quadrant 1, which of course any trig function of quadrant 1 is positive. Cosine pi over 4, pi over 4, there's 2 fingers on the left, square root of 2 over 2. So just positive. And then to simplify this, most of the time we will need to multiply by 2. Two times 1 is 2. 2 and 2 cancel out. 2 times 2 is 4. It's breaking the square root on the top and to the bottom. So we have square root of 2 plus square root of 2, and square 4 is 2. Right, now is that correct? Oops, sorry. It is in degree mode, which is correct. 22.5 degrees. And what we have is this fraction alpha y equal to, the square root first of, never mind, fraction on the top, square root 2 plus square root of 2, square root of 2, the bottom is 2. Yeah, so those are quite the same. I'm sorry, so I got a question here. Yes, of course, 15 is half of 30. So the key here is we're trying to write that as a half of something. I'm not going to ask you sine of 30 degrees. Even 30 is half of 60 degrees, because we know the values 0, 30, 45, 60, and 90. We don't know half of those. Like 15 degrees, half of 30, we don't know that. So that's why we have to do this by hand. And we write sine of 15 degrees as half of 30 degrees. Because 30 degrees divided by 2 is 15. By the way, there's also another way to do this from the previous section. We can also say 15 degrees, how about 45 degrees minus 30 degrees? That also works, and we use the formula of sine cosine minus cosine sine. Certainly we can use this, right? Because somehow we get from 15 degrees to something that resembling the formula. And 45 degrees minus 30, that's 15. That certainly works. Now, just because this one is right after the half angle formula, so I try to use the half angle formula. So in the half angle formula, when we have a half, it's going to be plus or minus square root. This is the full angle, so we're going to put 30 here and not 2 there. Right, yeah. So that is just u, not 2u. Right. Oh, we said if there's no 2 here, how do we get 30? By the way, notice the relation between the sine and that cosine. Whatever the angle in the cosine, it's going to be twice that. So that's why we don't need the 2 there. So once again, whatever angle we start with, it's going to be twice. Oh. No. The u over 2 is 15 degrees. So multiply 2 on both sides. So this is 15 degrees u over 2. And the u is equal to 30. So, yeah. That's why we don't multiply by In the formula, there's no multiply by 2, but it's going to be twice the angle we have. Just like this. 1/2 of, if we use in the degree mode, let's just say if we have cosine of 22.5, which is 45, so we start from the formula that have divided by 2. When we apply the formula, it will be the formula without divide by 2. No, this should be 30 degrees. That is not 15. U over 2 is 15, not U. U over 2 is 15 degrees, so U is 30 degrees. So, this should be 30 degrees, not 15. Right. So, in the formula, there's a divide by 2. After that, they don't divide by 2 anymore. So, just think about that way. So the formula original start with 2. After that, we don't divide by 2 anymore. Right. Sorry, I was confusing by putting the 2 at the beginning. I should not do that. If sine is negative 5 over 12, and theta in quadrant 3, sorry. Find the exact values. Sine of theta over 2. Right. So we see sine of theta over 2. So that obviously a half angle formula. So here sine of a half is equal to 1 minus cosine of the whole thing. So this is a half, this is a full, then divide by 2. Right. Tucked in. Thank you. Yeah, the calculation will be a lot easier if this is 13. Yeah, so didn't do that on purpose, so thank you. Right, so we have sine, we just need to find cosine. So a few things here. First, determine if it's positive or negative, and then after that find out cosine. So is that going to be positive or negative? So first, in quadrant 3 is about this, right? Which is going from pi to 3 pi over 2. So in quadrant 3 is equivalent to between 3 pi over 2 and pi. If that is more complicated, we just use degree. 270 degrees, yeah, much better, just use degree. Make that less than without the equal to. So no equal to, just less than. Not equal to. Alright, now, if that's what we have, right? Now, theta over 2, just divide by 2 on both sides. So 90 degrees, theta over 2, 270 divided by 2 is 135 degrees. Now, 90 degrees to 135. This is 19 to 135, so it is about this much, which is in quadrant 2. So theta is in quadrant 3, between 180 and 270. Cut that in half across the board, 90 degrees and 135 degrees. The angle is between that in quadrant 2. In quadrant 2, sine is negative. Sine is positive. Sine in quadrant 2, y over r, y is positive. So we use positive. And finally, we just need to determine what is cosine of theta. So, sine is negative 5 over 13. I'm going to use a triangle here. Sine is opposite over hypotenuse, or y over r. So r always positive, and y is negative 5. Let's need to find x, because cosine is x over r. X squared plus y squared is r squared. So x squared equal to r squared minus y squared. Yeah, so that's why it should be 13, because when we do this, that is 144. So x equal to plus or minus that. Now, again, should it be positive or negative? Remember, theta is in quadrant 3. In this part, x is negative. So, negative 12, and finally cosine is x over r. So we have cosine is negative 12 over 13. And we can put it back in there. Bottom line is sine of theta over 2 equal to half angle is in quadrant 2, so it's positive. 1 minus cosine is negative 12 over 13 divided by 2. Negative, so that's positive. Right, so what do we multiply in here to simplify this? Previously, since we divide by 2, so we multiply by 2 to kill the denominator there. So I will multiply in here by 13 to kill this 13. Times 1, 13 cancel. 2 times 13, 26. So square 25 over 26. Right. So I'm going to skip this one so that we can go to the next section. And they say we only have like 20 minutes. Yeah, but like I said, the next section is going to be should be enough for it. The test will go up to section 5.4, and 5.4 should be rather obvious. We have the formula, two formulas. I should say two set of formulas, and just apply that. Right, section 5.4. Product to sum and sum to product identities. So pretty much there are two set of formulas. The first one is product to sum, the other one is sum to product. Right. So cosine of u times cosine of v is 1/2 cosine of u minus v proving these identities are very simple. We just write down the formula for cosine of u minus v and cosine of u plus v, and then we add them, divide by 2. So it's very simple to prove this. We'll not even prove it. Once again, the proof is very simple. If you start with cosine of u minus v, sorry, should not cover that. Let's try to prove this one. Sine of u plus v is sine cosine plus cosine sine. And the sine of u minus v is sine cosine minus cosine sine. So just write the left hand side using the sum and difference identities, and when we reduce, some of this cancel out and double and cancel the two. So like I said, to substitute in and simplify. So that should be very simple. So that's why I don't think we need the proof. Just need to know how do we apply this, and that's all. See example. Find the exact values of sine of 15 degrees and sine of 75 degrees. Right. So I'll put the formula for the sum, product to sum here. That formula is over there. So we have a sine times a sine is 1/2 cosine of u minus v minus cosine of u plus v. So applying the formulas, put in the numbers. Sine of 15 degrees and sine of 75 degrees. So that is u and that is v. So 1/2 cosine of u minus v minus cosine of u plus v. Right, so 1/2 cosine 15 minus 75 is negative 60 degrees. And that is 90 degrees. Right. Cosine of 90, we still have degree mode, right? Okay, good. Cosine of 90, that is 0. So what is cosine of negative 60? Right. Now, we have the properties that cosine of negative x is equal to cosine of x, because cosine and secant are even. By the way, so if you're watching this video, make sure that on the next test, need to know which functions are even, which functions are odd. Cosine and secant are even, everything else is odd. Again, cosine and secant are even, the other function are odd, meaning sine is odd, cosecant is odd, tangent is odd, cotangent is odd. So 4 odd function and then 2 even function, cosine secant. Right, like I said, make sure you know that when you take the test. Because it is even, cosine of negative 60 is the same as cosine of 60 degree. So we just have 1/2 cosine of 60 degree, and cosine of 60 degree, one finger, so that's square root of 1/2, so it's 1/4. Right, like that. The formulas like this. I also, when you take the test, I assume that you have this formula somewhere, so you can go back to look it up. Suffice to say that I'm not going to ask you to memorize all of this, and it goes without saying. When you take the test at home, yeah. So I will not enforce the closed book, closed note. So you can pretty much use all the written note in class. Just don't use the internet or ask somebody else, because on the final it is recorded. Right. By the way, talking about the final, if you go to eCampus, there's a sample test for similar to the final. I encourage you to just try to take it and see if you can do it. If that doesn't work for you, there's an alternative. Anyway, just check the eCampus page. Right. So we have a sine times a cosine. So what formula do we have? Oh, a sine times a cosine. Straightforward. A sine times a cosine is sine of u minus v plus sine of u plus v. Right, so here u is 3 theta, cosine v is 5 theta, so sine of 3 theta minus 5 theta plus sine of 3 theta plus 5 theta. Uh, 3 minus 5 is minus 2. And sine of negative. Sine is an odd function, cosine is even, sine is odd. So that's why sine of negative is a negative sine. This will be positive. Sine of negative is a negative sine because sine is an odd function. So we have 1/2 sine of 8 theta minus sine of 2 theta. Just move things around so it will look better. Right. So we have that. Like I said, the question of this kind of question or the test should be very easy. Make sure we just use the formula properly. Right, so that was a product to sum identities. Product to sum identity. So go from a product to a sum. Next we will have a sum to product. Pretty much we have a sum and then we'll turn to a product. Right. sum two product identities. Right. Cosine of a plus is 2. By the way, let's use U and V because that's consistent to the formula that I sent you. So let's try again. We're going to stick with the formulas here because U and V usually easier to apply. So pretty straightforward. We skip the proof, just go to the example. So we're going to write this as a product. So we have a sine minus a sine. So we look for the formula that has a sine minus a sine, right? This one. Which is that one. Sine 4 theta my sine of 2 theta, sine u is 4 theta, v is 2 theta, so 4 theta minus 2 theta over 2. And then cosine 4 theta plus 2 theta divided by 2. 4 minus 2 is 2 theta. 2 theta divided by 2. And this is 6 theta divided by 2. So we just have 2 sine of theta and cosine of 3 theta. Right, pretty straightforward. Right, and next, simplify. Cosine 75 degrees plus cosine of 15 degrees. So we have a cosine plus cosine. This is a cosine plus cosine. So I'll look for the form and then just substitute in. U is 15 degrees, V is 15 degrees. (75 degrees) plus 15 degrees divided by 2. And 75 degrees minus 15 degrees divided by 2. Uh, 75 plus 15, that's 90 degrees. And 75 minus 15, that's 60. And that gives us 2 times cosine of 90 divided by 2 is 45 degrees. 60 divided by 2 is 30 degrees. Cosine 45 square root of 2 fingers on the left over 2. And cosine of 30 degrees 3 fingers on the left. Cancel our 2. We have square root of 6 over 2. Right. So that as far as we go in terms of sum to product, product to sum identities. That's all. This one we need for the second test. I'm going to post the test before tonight, and we highly recommend that you finish chapter 4, chapter 5, and then the review before you take the first take the second test. Right. Before I end the stream, do you have any question? Yes, the final is multiple choice. some of the question on the final exam, I require you to submit a copy of the work, but it's still multiple choice. I just need to see some of the work just for the partial grade and other things. But like I said, most of them are multiple choice. So it's safe to say most. You mean cosine of a sum or? Oh yes, I mean, yeah, definitely you have the sum and difference, these two. So the sum and the difference will be in there. The final exam, most of them are multiple choice, but cover everything we learn. In the class. By the way, I will not post a review for the final because we have review for test 1, test 2, and test 3 already. I'm not going to post the review for the final. What I will send out for the final is the list of the things that you need to know for the final. So something that you need to watch out for. That is a very long list, like 25 or 30 of things that you need to know. Right. So, do you have any other question? Yeah, I will send out an email about the final exam later. So at least you have a lot more information than it is right now. Right. So, if there is no other question,